we are getting very close to being ready to define what a relation is. But before that, one more concept to actually define, which is about tuples or order pairs. So given n sets over here, so we got S1, we got S1, we got S2, and all the way to Sn. So we got n sets over here. And we say that across products or Cartesian products of these sets is simply a set of n tuples. So the n here simply specifies how large the order pair is. For each pair, for each order pair, or for each tuple, how many elements are there in the tuple or the pair. Let's now take a look at the shape. So this is maybe the most convenient shape that we can write on the paper. But when you write into the tool, you may have to write something differently. But that's something we'll worry about later. Okay. So an n tuple over here tells you there are n elements in the tuple. So we got element 1, element 2, all the way to element n. You can think about element 1 is going to be drawn from S1, and element 2 is going to be drawn from S2, and etc. And element n is going to be drawn from Sn, right? And then it's going to be a comma separated list and surrounded by parentheses, right? It's more like it's like a pair, okay? And elements, each one of them with a member of the corresponding set, exactly what I just said, right? So this will be the formal definition. So let's say we write S1 cross product S2 cross product all the way to Sn, right? We're trying to do a cross products of n sets. And we're using a set comprehension notation over here to specify what the resulting set should be for the cross products. So every member in the set is going to be of an n tuple, and like a order pair of size n. So we got E1, E2, all the way to En, right? We got n elements in the pair, but it's a single pair. Every member in the set of the cross products is a single pair. It's a single tuple. And then, so this is the property, right? So here, I'm just being a little bit concise over here. I'm saying EI, while I here is an index. I will be from 1, between 1 and n. Well, think about I can be n possibilities, right? So E1 is a member of S1, right? What I said before, E1 is a member of S1. And also E2, where I is equal to 2, is a member of S2. So E2 is a member of S2, and etc. So we go this pattern between 1 and n, right? That's the beauty about math, that you can specify sophisticated concept, using very simple forms. All right, and let's now take a look at one example. I think this one is rather straightforward, so I don't need to illustrate on the paper. Let's take a look. So let's say we want to do the cross products between 3 sets, 1, and also 2, and also 3 over here, right? And question for you. So, well, that's a question for you to really see how you can derive the cross products. The result from cross product is going to be another set, right? What will be each member in the resulting cross products? The answer should be each member in the resulting cross product should be a 3 tuple, meaning that every tuple has size 3. The first element is drawn from either A or B, and the second element in the tuple is going to be drawn from 2 or 4, and the third element is going to be drawn from either $ or n%. Exactly the definition that we have over here. You can think about this set comprehension over here simply instantiates the definition for the cross products, right? So each member in the resulting cross product is going to be a 3 tuple with 3 elements, E1, E2, and E3. Specifically, E1 is drawn from AB, which is the first set over here. And E2 is going to be drawn from 2, 4, which is the second set over here in the middle for the cross product operation. Finally, E3 should be a member of $ and n%, and that one should be corresponding to the third set, right? So now, before I reveal what the next next line should be, tell me something. If we actually try to come up with we're using the set comprehension notation to implicitly tell you what the set should be, but now the answer should be spelled out explicitly about what each member should be. How many members in total are actually contained in this particular set? Give me a number. You can pause the video and think about it. Assuming that you thought about it, well, math again. Since there are 2 possibilities for E1, either, well, corresponding to the cardinality of this particular set over here, right? In the cross products. E1, we got 2 possible values. E2, we also got 2 possible values. And for E3, we also got 2 possible values. In total, we should really get 2 multiplied by 2 multiplied by 2. So we got 8. So the resulting set should be of size 8. Now, first of all, let's double check. So we got 1, 2, 3, 4. And also we got 1, 2, 3, 4. However, don't really just look at that and thought that you actually understood it. But let me just show you the pattern, which I arranged the members in the set over here. So you can see the first row, we only got A, and the second row, we only got B over here. So this one tells you that the first element can either be A or B, right? In the case the first element is actually A, we want to talk about the second part, right? Which can be either 2 or it can be 4, right? You can see these 2 elements where the first element, sorry, let me say it again. These 2 pairs, these 2 tuples where the first element is actually A. You can see their second element happened to be 2, which we chose over here. And these 2 elements, these 2 tuples where the first elements are also A, in that case, we actually chose the other elements from the second set, which is 4 over here, right? Hopefully you're following. And then you can see we also try to say, in the case where the second element happened to be 2 over here, in that case, we can, for the third element, it can either be $ or %, right? There's a pattern over here about numerating the resulting set of tuples, right? So I'm going to let you actually study this example. It's rather easy, and we're going to use the idea about cross products when we talk about relation construction, okay? I'm going to leave this to you, and then if you got any trouble, let me know.